In 9.1c, we're going to interpret a type 1 error and a type 2 error in context and give the consequences of each. So we're going back to the jury. Remember, in a jury trial, there are two errors that we can actually make in a jury trial. So let's first think about this one. What if you were found guilty when you really were innocent? So this here was our hypothesis, right? H sub O, we were saying you're innocent, but H sub A, we really think you're guilty. So if it came back that you were guilty when you were innocent, what happened is that someone said, you know what? We are going to actually end up concluding H sub A happened. So to conclude H sub A, what we had to do is reject H sub O. So if they conclude H sub A means we rejected H sub O when we should not have. So an error that could happen in your analysis is that you actually rejected H sub O when you should have never rejected H sub O. In this case, you should have said, I failed to reject H sub O and I cannot conclude that the person's guilty. Okay, what's the second error? The second error is this one. You were found innocent, which, careful, we're never going to actually find that you're truly innocent, but the case here was that you were guilty. So in this scenario, what happened? You really were guilty. You were H sub A, but they never concluded it. So what did they do? They said, hey, we failed to reject H sub O. We can't conclude H sub A in this thing. So the issue is someone failed to reject H sub O when they should have. And that would be a second type of error. There's a specific definition for each of these two types of errors. Let's talk about them. The two types have names. There's type 1 and there's type 2. A type 1 error is this. It happens when we reject H sub O when H sub O was actually a true statement. So in terms of probability, what that means, what's the probability of a type 1? Well, what's the probability I reject H sub O given that H sub O was true? That's what the definition of a type 1 error is, and this is the probability of a type 1. Okay, what's type 2? Well, a type 2 error is when you fail to reject H sub O when H sub O was actually false. Hey, we should have rejected H sub O. We did not. We should have, but we didn't. A good way to remember that this definition is type 2 is the same thing with 2. Type 2 in the word you failed to reject. That's how I make the connection. But let's look at all the possible outcomes we could have. So what's the truth about H sub O? Well, the truth is H sub O is either true or it's false. That's a fact. But what's the decision we make? Well, we either reject H sub O or we fail to reject H sub O. So based on that, there's 4 outcomes. 2 of these 4 outcomes have no issues. They were the correct conclusion. Which ones of these 4 are the correct conclusion? Well, let's think about it. If H sub O is false, I would say that I reject H sub O. So rejecting H sub O and H sub O false, this would be a correct conclusion. So that's correct. There's no error in that one. The other one is if H sub O is true, well, I want to fail to reject H sub O, right? In this box here, this is also a fair conclusion. These two are the ones where the type 1 and type 2 errors happen. Well, which one's type 1 and which is type 2? Remember type 1, you reject H sub O when H sub O was true. So we rejected H sub O when H sub O was true, so therefore this is the type 1 error. Okay, by definition of type 2, we failed to reject H sub O, which is right here, when H sub O is actually false, which is here. Therefore, this box is our type 2 error. You may ask yourself, why are these errors even happening? Hey, chapter 4, we designed our study well, and we carried it out, and it's set up great. Why do we have it? Well, these errors will happen, and they can happen. And the issue is they're caused by variability in the data collection process. Every sample is unique, and every sample has its own variability, and that in itself will cause some form, hopefully not to a large degree, type 1 and type 2 errors. This, a fast food example. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait for more than 2 minutes to receive their food. Based on store records, the proportion of customers who wait at least 2 minutes is 63%. That's the true population proportion. To reduce the proportion, the manager assigns additional employees to the drive-through window. During the next few months, he randomly collects a sample and tests the following hypothesis. Now, hopefully this hypothesis makes sense, right? True proportion is 63, but he's putting more money and more energy into the drive-through window. He's hoping this proportion goes down. That's what he wants to see. So define P is the true proportion of drive-through customers who have to wait more than 2 minutes. Okay. Describe a type 1 and a type 2 error in this setting and explain the consequences of it. Okay, so let's start with type 1. Type 1. In type 1, you would reject H sub O, but you shouldn't. So type 1, you would reject H sub O, and you would conclude H sub A, but we shouldn't have done that. What is going to be the issue? Well, if you do that, we would end up concluding that the proportion went down, but we shouldn't conclude the proportion went down. So here's the problem. If the manager decides the true proportion of drive-through customers have to wait less than 2 minutes has been reduced when it really hasn't been reduced, that's the problem. So he's going to think, great, this is working. It's really helped this new thing that I've done. So he thinks it's reduced it, but it hasn't. What consequence is that? Well, if you think about a consequence, he's been paying for these extra people to work the window. So a consequence is the manager will have to pay unnecessarily for additional employees. Basically, he's saying, great, H sub A happened, it went down, but it didn't. You're paying money and nothing is really happening. That's a type 1 error and its consequence. What about type 2? All right, on type 2, remember, that just means he failed to reject H sub A when he should have. He wanted to come back and he should have said H sub A was true, but he didn't. So what is going to be the issue with this? Well, the issue is this. If the manager didn't decide the true proportion of customers that had to wait at least 2 minutes had been reduced when it really had been reduced. So he's sitting here and he's thinking, yeah, I can't reject this and conclude H sub A. I can't do it. This just isn't working. I'm not actually reducing wait times. But you guys, it's a mistake. He really was reducing wait times. So what is the consequence of that? The consequence is the restaurant would not have additional employees helping the drive-through window, so they wouldn't be providing faster service when they could. If he didn't think those people were making a difference, he'd pull them off the window and not have them work. Guys, they were helping reduce the proportion of wait time. So by pulling the people off the window, he is ignoring that there was a type 2 error within his analysis. In part B here, suppose the manager decided to carry out this test using a random sample of 250 orders at a significance of 10%, or his alpha. What is the probability of making a type 1 error? So let's again just redefine type 1 error. Type 1 error is, it means we reject H sub O when H sub O is actually true. Dig into that just a little bit more. Here's what that really means. Let me talk about this statement. Okay, in a type 1 error, in this case, when the true proportion of customers have to wait less than 2 minutes remains at 63%. Okay. But we have a value of p hat small enough that the p-value is less than 10%. So look at here at this normal curve, because this is really where we're going to start going even more so. The p-value comes from approximately normal curves. The 63% is the true population proportion sitting here at the middle. So that's our mean. But remember, we're choosing an alpha of 10%. So if our probability is less than 10%, let's put this on the graph. Now, first of all, should I put my 10% on the upper tail or the lower tail? Well, our hypothesis was, remember H sub A, we thought P was less than 0.63, which means the less than says, nope, the 10%'s on this end. So drop a line and call that alpha. So this is alpha of 10%, which means this area in the blue region is my rejection region. That's what they're talking about here, is if I have this 10% as my rejection region, any p-value coming in this 10% or in this blue region, I'm going to say, you know what? My p is less than alpha. I'm going to reject H sub O and conclude H sub A. So this right here is actually called the type 1 error. Even more so, if alpha was set at 10% and everything below alpha is my rejection region, that's also my type 1 error. So really, it just comes down to this, that the type 1 error, the probability of it, is the actual alpha that I choose. Fine. What if I said alpha was at 5%? if I said, you know what, let's use a rejection region of 5%. Okay, I can do that. I'm going to come on in and I'm going to move this over to just 5% of the curve. Means anything in this tail, I would come in and say, you know what, reject H sub O, conclude H sub A. That just means I just changed my type 1 error. My type 1 error is the exact same thing as the alpha level that I choose. Now let's make one more connection. If the type 1 error is you reject H sub O when you shouldn't have, which is this region of the curve, well, this other part of the curve we didn't talk about is you failed to reject. This over here is your type 2 error. So your type 1 error is one side of the curve, the type 2 is the other. So realize that they're actually complements of each other. So to wrap that up, what is significance in type 1 error? Significance level is alpha of any fixed level test. It is the probability of the type 1 error. So it's a real easy one to remember. So whatever I choose for alpha is the probability of my type 1 error happening. Okay, keep this in mind. The smaller alpha, the larger the probability of making a type 2 error. So really, it's almost like the type 1 and the type 2 kind of go hand in hand. If I lower my probability for a type 1 error, it's going to raise my probability for a type 2 error. Conversely, if I raise my probability of a type 1, it lowers my probability for a type 2 error. Because by definition, the type 2 is I fail to reject, which is this region of the curve. So as this line moves, it's either going to make one region smaller and the other bigger, or it's going to make this region bigger and this one smaller. So type 1 and type 2 go hand in hand. Well, then people will say, okay, if type 1 impacts type 2, why not just use a small alpha to reduce my type 1 error? Well, that's true. I could easily reduce my type 1 error. Instead of using 10%, I'd use 5%. But you have to be careful. If you reduce your type 1 error, it will automatically increase your type 2. Are you okay with that? That's the problem. You would fail to reject H sub O and increase the type 2. So you have to decide in terms of the trade-off, which type of error would you prefer to have, a type 1 or a type 2? And you really just want to look at the context of your problem and see which one of these has the consequence you're willing to live with. Because they both will have a consequence of sorts.